protruding out in geothermal volcanoes, underwater volcanoes, spewing a chemical-like soup-like mixture to help sustain life that bacteria and thus more complex organisms can thrive off of and flourish. Okay, we're done with that. There's a picture I drew. I don't know if you guys saw it before, but here you go anyway. There we go. Show it. Okay. Number 7. Third Rock Radio. So Third Rock Radio is NASA's own radio that has that says like daily space information. I think they do like updates on like probes and Mars explorations and everything. So I just drew this. I hate how it's backwards. Like, anyway. So, NASA, I don't remember if they do, like, songs on this radio, but what I do know is that they do, like, information and updates and everything about that. And it's called Third Rock because Earth is the third rock from the sun. So, hey. Okay. Number 8, Milkdromeda. Milkdromeda is the name for a future collision. Or it's not really the process of, it's more like the final product of a process. And that process is the collision that is currently happening right now between the collision of Andromeda, our neighbor galaxy, our sister galaxy, and our own Milky Way. So, and don't get scared about like the end of the world. We're gonna become a rogue planet. We're going to be crushed into oblivion by another planet. No. It is the possibility of stuff crashing into each other is so little that it's little to none, really, because of the amount of empty space, the amount of billions of trillions of miles, the amount of thousands of light years of empty space between each celestial body, such as a star, a neutron, a black hole, etc. But even if that does happen, and we do get crushed to oblivion, Earth and humanity is going to be extinct way before that. Like, this is, I'm talking billions of years in the future. And so, Milkdromeda, milk from the Milky Way, Dromeda from Andromeda. I think you guys already knew that. So yeah, in a few billion years, they're going to be completely collided, like from one galaxy, 2 galaxies. They're really just going like that. So let me see how fast they are. How fast is Andromeda approaching the Milky Way? .68 miles a second. So yeah, pretty fast, but they're just so unbelievably huge that it's going to take billions of years for them to fully submerge with each other. So 110 kilometers per second, or 68 miles per second, as indicated by blue shift. I'm gonna look that up. Anyway, that one's done. So, hold on. I drew a picture, I think. It's really bad, but I tried. Here. For those of you who can read backwards, then this should be no problem for you. But those of you who cannot or have trouble reading it because you have like dyslexia or English is not your first language or anything, it's like I just did Milkdromeda, bracket under milk, Milky Way, Dromeda, bracket under Andromeda, Andromeda. That's basically all. Anyway, number 9. This is gonna be a mouthful, but I'm so fascinated with this, and I've said it so many times that it's really no problem with me. It's not as big as a problem for me to say than most people I know. Hercules Corona Borealis Great Wall, or the Great HCBGW. Yeah, a mouthful. It is, from what I know of, the largest structure we've ever found in space, ever. It is a group of galaxies, and from here it looks like just a bunch of swirls. But every single dot is a galaxy. And what I find so fascinating about this is I think it's 15 billion light years wide or something like that. Let me look at it. I'm doing a lot of Googling during my video of astronomy that I should probably already know. Anyway, I'm just looking it up right now. Yep. It is. No, it's 10 billion light years long, 7.2 billion light years wide, and almost 1 billion light years thick. So, whether it was 7.2 billion light years wide or 15 billion light years wide, it would seem never ending to us. So, same difference. Don't judge me. Anyway, this thing is so huge that to our understanding of physics, space, time itself, and everything else like that, then this should not exist. It is too big to be physically possible because of how ginormous it is. And something else I found is that it's believed that it took less time to form than our own Milky Way, and the Milky Way is a tiny dust particle. It's smaller than a dust particle relative to this thing. It is so unbelievably huge compared to our Milky Way, and that just makes you look at yourself as a human and how little and insignificant your problems are. Sounds pessimistic, but it's true, unfortunately. Anyway, this thing is so big that in the little time it took to form, is at least 1 billion years quicker than it took to form the Milky Way, which is impossible to our understanding of physics and should not exist. Again, this is why astronomy fascinates me, because you can find one tiny little thing and it throws your beliefs and ideas out, like, away. Like, look up black holes. It takes everything we know to the extreme. Temperature, time, bending space and time, space itself, density, etc. I'm going off topic, I'm sorry. Anyway, that's done, and number 10 is chirps. I'm pretty sure this video is gonna end soon, so I'm just gonna try to say this really quickly. So chirps is when two black holes are colliding, 2 or more, I'm pretty sure, and when they finally collide, it sounds like a chirp, or a drop of water falling onto a lake. Here's a picture. And there you go. It's my 10 facts I wanted to share. Sorry it took like, 4 videos to take? I don't know. I'm bad at explaining things. It takes forever. And my phone stops by itself, so bye. Should I do more? I want to do more, but I don't want to bore anybody, you know? Because I'm one of the only people who can talk about this passionately and not get bored of it, like, ever. Like, as you can tell. Bye.